Welcome back to the second part of the video for section 7.3. In 7.3, we're looking at two different patterns that come up when multiplying binomials. The first one was the square of a binomial. That was in part one of this video for 7.3. And the second pattern, and the last one, is called the sum and difference pattern. So take a look at this. It's called the sum and difference pattern because what it is, it's a pattern that is actually very common that comes up when you multiply two binomials where one is a sum and one is a difference, but they have the same terms, like x plus 7 times x minus 7. And what ends up happening is really cool. This is a pattern that most students eventually learn to take the shortcut really quickly. So let's multiply it out and see what happens. So x times x equals x squared, and x times negative 7 is negative 7x. And 7 times x is positive 7x. And then lastly, 7 times negative 7 is negative 49. Then you look for the like terms, and you'll notice that the like terms are actually opposites of each other, negative 7x and positive 7x. So they cross each other out, and you're left with x squared minus 49. So the answer is actually this binomial here, because the middle terms crossed out. And that's going to happen every time when you have this pattern. By the way, you should know this, and you can start knowing this now because it's going to come up in the next few sections. This binomial here is called a difference of squares. And I'm going to be saying that word a lot in the next few weeks, so I might as well get you used to it now. The answer is called a difference of squares. The reason is it's a difference because there's a minus, and of squares because each of these is a perfect square. So x squared is a perfect square, and 49 is also a perfect square because 49 is really 7 squared. So it's x squared minus 7 squared, a difference of squares. Okay, I would like for you to try one. And let's try this. Let's try x plus 9 times x minus 9. I wonder if you can come up with the answer without even doing this. All right, you try it out, and if you get it right this time, then I will eat the chocolate because I want to be fair. Last time I rewarded myself, for being right, and this time I'm going to reward you. So if you're right, then I'll eat the chocolate. Your reward, see? Go ahead, try it. I hope you did this. So x times x is x squared, and x times negative 9 is negative 9x, and 9 times x is positive 9x. And 9 times negative 9 is negative 81. The two middle terms cross out, and you're left with x squared minus 81. That is another difference of squares, because it's really x squared minus 9 squared. And that is your answer. So let me ask you, this is important. Did you get it right? You did? Awesome. You know what that means? That means I get a chocolate. I appreciate that very much. Now, while I'm eating this chocolate, I would like for you to try another one that's a little more complex and see if you can figure this out. So let me write this down for you. So we're going to try 2a minus 5b times 2a plus 5b. Try that one. You may need to pause the video. Yeah. Pause the video while I eat this. Almonds. I like almonds in my chocolate too. I like these chocolates that have a variety. Some with almonds, some are dark, some are light. It's good stuff. Here's what you should have. 2a times 2a is 4a squared. 2a times 5b is 10ab. Negative 5b times 2a is negative 10ab. Careful on that. And negative 5b times positive 5b is negative 25b squared. These middle terms cross out. And your answer is 4a squared minus 25b squared. So there you go. Very often, after doing this pattern, students will eventually stop multiplying it out, showing their work, because they're like, I get it, I know what this is going to make. But show your work as long as you need to. Make sure that you understand what is happening. All right, to finish this off, let me just show you something that's kind of cool. I, as your math teacher, happen to know that 14 times 16 equals 224. Many of my students in pre-calculus these students are really good, they also can do that in their head. And do you know how they do that in their head? I'll show you how they do that in their head. It's kind of neat, and it has to do with this pattern. You don't really need to know this. This is a bonus. They know that 14 is 15 minus 1, and they know that 16 is 15 plus 1. You notice that that is simply the pattern that we've been doing. So they know that distributing, it's going to end up being 15 times 15, which is 225. They happen to memorize that, minus 1 times 1, which is 1, and therefore it's 224. How cool is that? See, these are the kind of ways that we cheat when we actually do multiplication. So we know this pattern. So for example, if I were to do now 13 times 17, I know the answer is 221. I have no doubt about it. And I didn't actually multiply 13 times 17. What I did was this. I did 15 minus 2 times 15 plus 2, which is 225 minus 4, based upon the pattern that we just studied. And this can be done with almost anything. Kind of cool, huh? So sometimes when Mr. Peretti will be in class and you guys think I'm a brilliant person for knowing that 32 times 28 equals 896, I just made that up. It's not that I have memorized 32 times 28, it's that I know this trick. All right, math is cool. I will see you guys next week. Make sure you come to the meets. We're going to practice stuff and write equations. You got to be at the meets if you really want to learn this. Okay, I'll see you soon.